Hello everyone. We the students of College of Engineering Pune under the guidance of Dr. Abhishek Patange are presenting a project which the following students have completed under the project-based learning scheme of our subject analysis and synthesis of mechanism which goes by the name of walk assist. In this world, almost 600 to 650 million people will suffer from physical deformities, out of which statistics suggest that leg impairment is the most common. Generally, at the age of 60 and 65, our body tends to start malfunctioning. Joint pains, body pains become common, thereby restricting our movement. Else, there might be cases where deformities might occur if an individual encounters an unfortunate incident like road accident or makes any kind of untimely or sudden movement, which is common in sport activities such as ankle twist, ligament tear, etc. Hence, we as responsible engineers, by the means of this initiative of project-based learning under the guidance of our teacher, have tried to analyze and synthesize a mechanism to overcome this problem that we discussed earlier. The following is a series of analysis which is made by third year BTech students in reference to the given problem by building a mechanism as an assist to walk to those in difficulty so that we can provide an effective, customizable, and cheap engineering solution to those in need. Our approach. Our approach to tackle this problem was to firstly analyze the root cause for the difficulty in walking, as this would definitely give us a direction to carry out a systematic procedure for choosing the appropriate mechanism. Hence, we've devised a way to provide an extra effort or movement to the injured leg and employ a mechanism to restrict the flexing action to prevent any kind of hyperextension. The following slides show the systematic procedure that we carried out for this project. Analysis of the mechanism. Before the analysis, there are a couple of assumptions that we made. Angle subtended by the thigh and vertical is negligible, and also the angle subtended by the hydraulic cylinder with the vertical is negligible.
So, the next point that we will discuss is what data that we took to undertake this project. The average height of a person that we are considering is about 5 feet 6 inches. We just googled and found out that the average flexing angle that a leg moves with respect to the vertical axis while walking is approximately 25 degrees. Length of the thighs for an average person is 0.5 meters. Length of the legs for an average person is 0.47 meters. And the motor that we are using to lift up the legs is placed exactly at the center of the thigh. So the next is the free body diagram. Here L1 represents the length of the thigh, that is equal to 0.5 meters, followed by L2 that represents the length of the leg, that is equal to 0.47 meters. Theta is nothing but the angle that the leg moves with respect to the vertical, that is equal to 25 degrees. And F1 is the weight of the leg that is acting at the center of gravity of the leg, that is equal to 37.8 Newton. Hence we need to find F2, that is nothing but the force or the tension present in the string, and that is also the force that is required to make the leg rise, followed by T, that is torque, of the motor, omega of the leg, and P the power of the motor. Coming up, the functioning of a mechanism. The basic functioning of a project starts with the external motor providing the torque, which would be enough to lift the leg up to an angle of 25 degrees with the vertical. As the leg makes 25 degrees, a flex sensor provided behind the knee stops the motion of the motor, and the action of the hydraulic supports damping. Now what the above statement means is, we have a motor present exactly at the center of the thigh, which is being used to lift the leg by the means of a string. When the motor is on, it is providing us with the lifting force. Now what happens is, after the leg reaches 25 degrees, the flex sensor directs the motor to turn off, while the hydraulic being used helps in providing damping. Now, for the return motion of the lifted leg, the motor stays in the off condition, while the hydraulic provided helps to make the leg descend down to complete one stride of fall. The hydraulic being used also helps in providing structural support while walking apart from damping.
Mechanism analysis and synthesis. In this, first we will see calculations for degree of freedom. Here we are assuming the movements of thigh and the cylinder as negligible. Therefore, they will be considered as the fixed link. Therefore, there are four number of links and number of joints are also four, which includes the joint between the thigh and the leg, between leg and the connecting link, between connecting link and the piston, between piston and the cylinder. So, the degree of freedom is calculated, and which comes to be 1. That shows that we have to give only one input to cause the movement of whole mechanism. Now, we will see calculations for the length of thread. Here, we are connecting the motor at the center of the thigh. that is 0.25 meter from the knee, and leg is making angle of 25 degree with vertical, which is its extreme position. So as we know the lengths of leg and thigh and the angle between leg and thigh, we can calculate the length of thread, and by which we can also calculate the angle between the thread and the leg, that is theta. So now to select the motor, we should know the maximum torque that should be applied by the motor on the leg. So now we will see the torque calculations. Here, the forces acting on the leg are due to the motor, that is along the thread, and the self weight of the leg. Weight of the leg is acting along the center of gravity of the leg, and the force F, that is due to the motor, is acting at the bottom of the leg, that is at the foot. So now we resolve these two forces along the leg and in the direction perpendicular to leg. So now when we will take the moment about the knee, the moment due to forces acting along the leg will be 0. So now for the movement of the leg due to motor, the F sine 10 into 0.47 should be greater than FCG sine 25 into 0.285. By taking this condition, we will calculate force applied by the motor F, and then we will calculate the torque that should be applied by the motor, considering the radius of the pulley as 0.05 meter.
We will be talking about the velocity calculations. The basic need for this calculation is to fix a motor with a specific RPM required. So we will be dealing with the maximum conditions, that is the minimum time required per person to walk. So we have calculated the angular velocity of the leg of an average walking person. From this angular velocity we know the decrease in the length of the string that is being pulled by the motor in a given time, and from this we get linear velocity of the string, that is the linear velocity of the pulley, and with the help of the diameter or the radius of the pulley we could actually find the angular velocity of the motor. Now we will be talking about the velocity and acceleration diagram. So as referring to the figure, we have assumed that thigh and cylinder to be fixed because the moment of thigh and cylinder is very negligible as compared to the other parts, and also with the absolute positions, that is they must obtain a very less angle with the vertical during their motion. So to make the calculation part easier and comprehensive, we have actually assumed it. So talking about the velocity diagram, we consider the linear velocity of B with respect to A, and then C with respect to B, and then C with respect to the origin, that is OA. So we get our velocity diagram as follows. Next, calculating the acceleration diagram. We now know the velocity of each link, and thus we can calculate the acceleration diagram from it. So the steps are as follows. We calculate the centripetal acceleration of B with respect to A, and EB, that is the leg, will be rotating with a constant angular velocity, so it's only having a centripetal acceleration. Then we will be considering centripetal acceleration of C with respect to B, as we are having the angular velocity of C with respect to B, but we do not have the tangential acceleration of C with respect to B, so we will be sketching a horizontal line from C dash, and we know that the motion of C with respect to O is vertical, and thus the acceleration will also follows the same path. So we sketch out a vertical line from origin OA, and the intersection of C dash line and O dash O to C dash line intersect, and this intersection gives us C.
Now we move on to the next, that is the simulation and the working model. Devices and materials. First is belt or a rope that connects the motor to the leg, followed by a flex sensor, that is a device to keep the track of the flex angle 25 degrees in this case. A motor that is being used to provide the required RPM and torque to lift the leg. A hydraulic to provide damping and fluxural support, followed by Arduino, that is nothing but a microcontroller being used for controlling the motor. The simulation. The simulation was done on SolidWorks. Here, the thigh and the leg are considered as links, followed by hydraulic, which is being used to provide damping, while a motor is being used to lift the leg, which is present exactly at the center of the thigh. Here, 1, 2, 3, 4 represent the subsequent movement of the link while a person moves a step while walking. You can note here that the hydraulic being used also helps as a support. Working model. We also made a simple model to show the working of the motor pulley mechanism using some parts. You can note here that how a pulley mechanism is being used to lift the leg up while a person takes a step while walking. The final point that we will discuss is the sensor circuit. We used an Arduino UNO, that is an open source electronic microcontroller, a DIY made flex sensor, a servo motor, and some jumper wires to show the working of the motor used for the pulley mechanism. We have come to the end of our presentation. Hence, in this project, we were able to analyze, devise, and fabricate a solution to a real life problem using the concepts of machines and mechanisms and basic electronics. This engineered solution on fabrication and further development can cater to those in need at a cheaper rate than those available now. We sincerely thank our guide, Dr. Abhishek Patangi, for coming up with project-based learning initiative, which gave us an opportunity to think out of the box and to come up with engineering solutions to solve daily life practical problems. We would like to end this presentation by a famous quote. It's not just about ideas, rather, it's about making ideas happen. Solving daily life problems is where the crux of engineering lives. So by this, we conclude our presentation. Thank you.